In this scene, a U.S. Geological Survey technician, Sean Cutshaw, is working at an especially important site on Buffalo Creek. The stream gauge near Wheeling is where instruments in Buffalo Creek take continuous measurements and transmit them from the nearby tower to USGS. During his visits every 6 weeks or so, Sean checks those instruments, records the current stream stage, verifies the peak stream height since his last visit, and uses his flow meter to measure water depth and velocity at many points across the stream channel. These measurements are used to calculate the volume of stream water flowing past this point in cubic feet per second. A rating curve is used to convert continuous readings from the pressure sensor at the bottom of the stream under the bridge into the volumetric stream flow data for this gauge. The bridge itself is an important part of the gauge, since the concrete structure maintains a predictable relationship between water depth and flow rate. Although Sean's flow meter uses new acoustic Doppler technology, the USGS has been using the same basic approach to monitor stream flow in Buffalo Creek for more than 60 years. These stream flow data, along with similar data from numerous gauges across Chicagoland, are used to anticipate floods downstream on the Des Plaines River. Anyone can access the real-time stream flow data, as well as historical statistics for this site on the USGS website. During the 60-plus years the USGS has been monitoring stream flow, population in the Buffalo Creek watershed has increased from less than 5,000 to nearly 80,000 people. The average annual stream flow has increased by more than 50%, despite an increase of only 15% in precipitation in that time. Scientists who study stream flow believe that the main cause of this trend is an increase in impervious surfaces, the roads, roofs, driveways, and parking lots that result from development. Depending on where you are in the Buffalo Creek watershed, the percentage of impervious surfaces can vary widely from only 3% in the forest preserves up to 35% or more in some heavily developed areas. Impervious surfaces prevent rainwater from soaking into the soil and becoming groundwater. Instead, stormwater quickly runs over the surface into storm sewers, roads, and eventually into the streams. Since the watershed no longer retains as much groundwater, downstream flooding is worsened. And because the stormwater enters streams so quickly, the stream flow velocities are higher, causing severe erosion. In addition, the water running off of roads and parking lots and even lawns contains more nutrients, metals, and organic toxins. The combined effects of flooding, erosion, and pollution cause damage to sensitive habitats that once supported a wide range of plant and animal life.